So, gentlemen, for the benefit of our viewers and listeners, maybe you could give us a little hands-on explanation of the actual functioning of this technology.
Sure thing.
Yeah, very good. We happen to have a scale model of the critical downhole components, specifically the downhole wet mate connect. That's the enabling technology that allowed this all to go. So we'll go through a quick explanation of it. This is the part we were talking about called the permanent completion that's been run downhole. It basically is a downhole wet mate connect where we essentially plug in the motor. This is what we call the annular connection port. It's been run in the well behind us yesterday, and the cable itself is run to the surface and through the tubing tree. Basic, as John said, it's designed to be a full bore system when the pump is pulled out of it that allows customer to access their intelligent completion below the well for either opening and closing valves or logging. We also run a permanent cable, and in this case our cable was designed to be life of the completion cable, not life of the well. So we use a very unique piece Morteza has in his hands there. It's a ESP cable, but it has solid metal tubes around each of the conductors. And that allows us to do metal to metal seals all the way from the wet mate connector here all the way to and through the tree to the surface. So everything's metal to metal connection through the tree. When you look at this piece, because we run our system on sick line, we have a no-go, so the sick line operator you see in the background can orient where he's at in the well. Then we have a B profile that he pulls up to, and it pops open an orientation pin that's going to travel in this groove to align the female plug into the window here. And then when the sick line operator sets down, it plugs the female part into the male part, and we'll show you exactly how that works. So what you're looking at here is what we call the fixed end. It's where we make the plug of the motor into the cable itself. If you look at these little pieces, they're metal bellows, so all of our connections in the system are positive pressure dielectric fluid on the inside, maintained by a little metal bellows here. So completion or dielectric fluid all the way in here. We plug the cable in using a dry mate connector, and then the cable Morteza just showed you runs to the surface. So this piece is in the ground and set. What we're doing out here today is running the motor in the ground to plug in. So this piece we call the plug arm. It has a permanent gauge that runs downhole to tell us how the ESP is functioning. We have the permanent magnet motor and then a set of seals that equalize pressure inside the system. So what the suck line operator does is he runs the system in the hole. It runs all the way in till it hits a no-go, and that way he knows exactly where he's at. He pulls up until he lands in the B profile here, and it causes an overpull on the sick line unit. He has to overpull, and that shears a pin that pops into the orientation port. If you look here in the window, you can see the tool turning around until the female plug gets in the window, and then straight down for us, you can see right here, we make the plug, and now we're electrically connected to the motor, and the motor now functions as a conventional ESP motor. You can see phase to phase and phase to ground electrical checks the same as you would on a conventional ESP. Then when we got here this morning, they were running the pumps. That's the next piece. They just run straight in and it runs the pumps. Then they ran a little tubing pack off, and currently they're running this little piece called the tubing stop that just holds everything down in the event of a slug might hit. So fluid flow in this system is from the reservoir. It can either come out into a shroud here, but it flows up along the outside of this piece, in here, up along inside the tubing into the pump intake, gets boosted and produced all the way up the tubing to the surface. So then when it's time to retrieve the system, it's the exact opposite. You pull the first piece, this tubing stop, a very small, simple mechanical piece. Then you pull the tubing pack off. It's a release this packer, let it bleed off, pull it out. Then you pull the pumps. And I should mention, these pieces are not to scale. These smaller ones are, or the larger ones. Then to release the motor and unplug it, it's just a straight over pull. It unplugs the motor, the whole motor comes out of the system, and you change it out and run back in. So you could see this permanent completion stays in the well for the life of the well. These you can come out with the slick line unit, pull and rerun very quickly and very inexpensively. Whereas offshore, as I said, that process would take $15 million. With the slick line showing what I just showed you, it's about $200,000. So significant rig time saving.
folks, you can see for yourselves here, there's nothing like being able to visualize it directly. Thank you, gentlemen, for an excellent demonstration of the technology.